Hey, Tim DeStasio here. It is Psychrometric Saturday, and a couple of weeks ago, I made the statement, you cannot HVAC your way out of a bad envelope. And here's what I mean about it. Sometimes we have a situation where our air conditioning unit may be able to maintain the sensible heat, may be able to maintain temperature in the space, but it can't maintain the humidity in the space. And so if we don't look at the thermal envelope and we simply throw more HVAC at it, for example, if we throw a dehumidifier, a really big dehumidifier at it without addressing the envelope, we can make a bad problem worse. Let me give you an example. Let's say that we've got a 2-ton air conditioning unit and it moves 800 CFMs, and we've got a load that's 18,000 sensible, 6,000 latent. That totals up to 24,000 and a 0.75 sensible heat ratio. Here's our sensible heat line. Now, as we've talked about before, in order for our air conditioning unit to keep up, we need to be delivering supply air temperature that's in this quadrant, below this line. Well, this unit may be getting 75 dry bulb in, 55 degree dew point in, and it's making 55 degree dry bulb supply air and 52 degree dew point air, but we are above that line. We're not in this quadrant. We're in this little quadrant right here. So of course our unit cannot maintain the humidity. Now we throw in a really big 120 pint dehumidifier that moves an additional 300 CFMs. So we've got 800 and 300, and we're delivering air that's mixing these two air streams together. And our dehumidifier makes air that's really hot and humid, way over here, 96 degrees dry bulb and 45 degree dew point. So here's our dehumidified supply air stream. We merge these two supply air streams together, they mix together, and the result that comes out of our supply registers is 65 degree dry bulb and 50 degrees dew point. So here's the air that comes out of the vents. Well, you may say, well, we're now below this little line right here. We're in the right quadrant. So we should be able to maintain conditions, right? Well, we need to be able to move enough of this air in order to maintain those conditions. So how do we know how much air we would have to move? We've got to take our sensible heat formula, we flip it around, we solve for CFMs. Here's what that formula looks like. Our CFMs is our sensible load, which in this case is 18,000, divided by, and then in parentheses, so we got to do this part first, 1.1 times our temperature difference. Now in this case, our temperature difference of entering and leaving air is only 10 degrees, 75 and 65. So when we do that math, we come up with 18,000 divided by 11, or 1,636 CFMs. This is how much of that air we would need to move at these conditions to be able to maintain those conditions. Well, are we moving 1,636 CFMs? No, we're moving 1,100 CFMs, 800 plus 300. So we're not moving enough of this air. So let's think about what we just did. We sold the customer a dehumidifier, but now their air conditioning system struggles to keep up even with temperature. So struggling with humidity before, now we're struggling with temperature, and we probably are still struggling with humidity as well. And that's all because we did not address the thermal envelope. The problem here is we have way too much latent load, and it's so much that our air conditioning unit, even when it's running on a really hot day, running constantly, it can't keep up. Our AC system should be able to keep up on a design day, both in sensible and latent capacity, and that's per manual S. When we ignore manual S and we just throw a dehumidifier at it, this is what happens. We make a bad problem worse. They spent thousands of dollars on a dehumidifier. Now their unit can't keep up in the summertime, and they've got higher energy bills. If you were the customer, would you be happy with that result? Of course not. And this is why we as practitioners need to be addressing the thermal envelope. If we can get this latent load down, now all of a sudden our sensible heat ratio is something that's a little bit more reasonable. And now the air conditioning unit once again puts out air that is in the right quadrant. And our dehumidifier is just there for low load days when the AC unit is cycling on, cycling off a lot more. The dehumidifier picks up some of that slack. Yes, it does add sensible heat, but is doing so on a lower sensible day, and we've got some sensible capacity to spare. I know it threw a lot at you, but that's because HVAC isn't that hard, right? Well, of course not, especially when you look at psychrometrics. Thanks for joining me this time on Psychrometric Saturday. We'll see you next time.